Artificial intelligence plays a central role in how Spotify connects users to music they'll enjoy. And much like Netflix, the process goes far beyond simply looking at popular trends. Spotify's AI is designed to learn individual listening patterns, understand musical characteristics at a granular level, and continuously refine its suggestions in real time. This allows the platform to serve both longtime favorites and fresh discoveries that feel personally curated. By unpacking how Spotify's system works, we can see another example of AI observing user behavior, interpreting content, and adapting to preferences, principles that will later connect directly to educational applications. Spotify's recommendation engine is built on machine learning models trained on massive datasets. These datasets include billions of streams, skips, playlist additions, song saves, and listening times, all tied to specific users and contexts. Every time a listener chooses to finish a track, skip ahead, replay, or add a song to a playlist, that information becomes input for models predicting future musical preferences. Spotify uses collaborative filtering to group listeners with similar behavior patterns. If listener A and listener B share a high overlap in the tracks they enjoy, and listener A discovers a new song, there's a strong probability that listener B will like it too. This is especially useful for surfacing tracks that aren't yet globally popular but are gaining momentum within certain listener clusters. Unlike video platforms, Spotify has access to the raw audio data itself, and they make full use of it. They employ signal processing and deep learning techniques to break down every track into measurable features: tempo, key, time signature, loudness, energy, danceability, acousticness, instrumentalness, speechiness, and more. These features are then represented as vectors in a high-dimensional space, similar to how Netflix represents movies and shows. Songs that sit close together in this space share musical qualities, and if a user enjoys one, the system can recommend others nearby in that vector space, even if they've never been on the same playlist or genre chart. Natural language processing (NLP). Spotify also applies NLP models to analyze non-audio content like artist biographies, album reviews, music blogs, and even social media posts about songs and artists. By extracting sentiment and keywords, the system can detect cultural and emotional associations that help improve recommendations. For example, two songs may sound different musically, but both get described in online reviews as atmospheric, introspective, and cinematic. This connection can help Spotify suggest the second song to fans of the first, even if traditional genre tags wouldn't link them. Playlist generation and personalization. One of Spotify's most well-known AI-powered features is personalized playlists, such as Discover Weekly, Release Radar, and Daily Mix. These playlists are dynamically created for each user, using a blend of collaborative filtering, content-based similarity, and contextual factors. Here's the cycle. The system identifies a pool of candidate tracks from collaborative filtering. It refines the pool using content-based analysis to match musical attributes the listener tends to enjoy. It adjusts the mix for variety, ensuring not all songs sound identical. It personalizes the track ordering for optimal engagement, balancing safe bets with opportunities for discovery. Contextual recommendations and session-based models. Spotify doesn't just ask, "What does this listener like?" It asks, "What's the right song right now?" Session-based recommendation models analyze listening behavior within a single session to make predictions about the next track. For example, if you start with a high-energy track on a workout playlist, the system may maintain the energy level for several songs before gradually tapering down for a cooldown. Conversely, if your session starts with slower acoustic tracks, it will likely keep you in that mood, rather than jumping to dance pop. These models take into account time of day, device type, location patterns, and even how quickly you're skipping songs to fine-tune their recommendations in real time. Reinforcement learning for long-term engagement. Spotify's AI is also tuned for long-term user satisfaction, not just short-term clicks. This means balancing novelty with familiarity. Too much new content, and users may feel disconnected. Too much repetition, and the experience becomes stale. Reinforcement learning helps the system learn over time which balance keeps you engaged and returning. Like Netflix, Spotify conducts constant A/B testing to refine its algorithms. These tests might involve trying different track orders, adjusting playlist lengths, or introducing subtle interface changes to encourage discovery. The results feed directly back into the recommendation models, which are updated frequently. With over 600 million monthly active users, Spotify's AI must operate at incredible scale, processing billions of listening events per day with minimal latency. This requires distributed computing, efficient model deployment, and caching strategies to ensure recommendations feel instant. The broader implication mirrors what we saw with Netflix. AI can process massive amounts of behavioral and content data, learn patterns, and respond with hyper-personalized recommendations. While Spotify uses this power to guide musical discovery, the same framework could be applied in education, recommending learning materials, exercises, or even pacing strategies uniquely suited to each student's needs. And that's the connective thread. The AI that helps you find your next favorite song is built on the same foundation that could one day help a learner find the perfect next step in their educational journey.